All right, in our quest on inequalities, we're going to take a look at unions and intersection of sets. And what we're going to see is another notation for inequalities. In this particular situation, 50 students, they were polled about their after-school activities. Some students just do one activity and some students do two. And when they do two, there is some overlap that happens there. And we got to take that in consideration. And then there's some that do all three, which includes the very beginning or the middle of all that. And that is an intersection of all three places. So we're going to look at these things from in a notation perspective and even creating Venn diagrams. The first part we need to keep an eye on is when you're given two or more sets, you can describe which elements belong to at least one set and then which elements belong to all the sets. The first part of it is looking at the union of them, and we use the symbol here, which just conveniently looks like a U, just stretched out a little bit. So this phrase right here is talking about the union of set A and B, and that's going to include all of our data, everything that sits in all entire Venn diagram. I want to know what's in all of it. What's all the information? In your left pocket, you have a quarter, a paperclip, and a key. In your right pocket, you have a penny, a quarter, a pencil, and a marble. Not sure why you would have a marble, but in this case, you do have a marble. What set represents the different items in your pockets? So in your left pocket here, you have the set, quarter, paperclip, and key. In your right pocket, you have a penny, a quarter, a pencil, and that marble. But if you're looking at the union of them, the union of your left pocket and your right pocket, we put it all together, a quarter, paperclip, key, pencil, penny, pencil, and a marble. Now notice that a quarter is in both of them, but we only indicate it once. We don't want to indicate something twice when there is that overlap. You just want to say it once. I'm going to have you try yourself. So go ahead and press pause, and let's see how you did. So we can see that the union of set P and Q is 1, 2, 3, 4, 5 because it's including all of the information. And notice that there's some points where they intersect, but we're only going to mark them once in the union. For B, it says what's true about when one set is a subset of the other. It's going to include everything in that set. An intersection is another thing that can happen, and that is that middle point where two things come together as indicated by this symbol. It's like that upside down union. And so we can see in this shape right here, that symbol right here is indicating us that the intersection of set A and set B show up in the Venn diagram in that intersection part. There's also something that can happen called a disjointed set, where there are no elements in common. In that case, there will be no intersection on this one. And that can happen too. If there's no intersection that happens, we would indicate that a null set or an empty set. So you can have a union, you can have an intersection, and you can have a disjoint. Those are kind of the three types of things that are playing out here. So let's look at the intersection of sets. Set X is X such that X is natural numbers less than 19. We have set Y where Y such that Y is an odd integer. And we have set Z where Z is such that Z is a multiple of 6. So we're looking here. This is going to be the intersection of X and Z. So we're looking for a list of the elements that are both natural numbers less than 19 and multiples of 6. So we can see that when we're talking about an intersection, we're looking at the AND concept. Something that the numbers that qualify for that is 6, 12, and 18. Now we're going to also look for the union here, so we want another AND. So list elements that are both odd and multiples of 6. So odd and multiples of 6, and nothing actually works for that. There's nothing that fits for that, so we would call that an empty set or a null set. I want you to give it a try. So I want you to press pause, and let's have you do that as well. Now, if you can recall when we were working on identifying the different sets that play out when you have a number system here, one of them that didn't show up was a null set or an empty set, and it plays out here. That is a viable solution to a situation. There is no overlap here. I've noticed somebody do this once too. Union is the U, and when they look at AND, they see this little symbol, and they put a line across it to make a letter A. Here, let me make it bigger. They see it like as an and. It's like the capital A. Venn diagrams play out in situations. Sometimes there's three things. Like here, there are three backpacks with stuff in them. And you can see on our Venn diagram, we have an intersection of three things where the water, the hat, and the map are in all three backpacks. We can see that in the yellow backpack and the red backpack, they both have a pan, but it's not in the blue backpack. That plays out here. And there's even a null set in here, right here, an empty set. It's actually literally empty in the Venn diagram. So there's nothing that's in the yellow bag that's also in the blue bag. And a Venn diagram will show us that. Okay, for this one, I want you to go ahead and try it out, but I'd like you to create a Venn diagram also for this to show your answer to it. So press pause and draw away. So I'm trying to find the answer to what letters are in all three sets, and my Venn diagram shows kind of strewn all over the place, but I do have some that are an intersection of all three sets. A and E is found in all three sets. All right, in this particular situation, we have 500 commuters polled, so I'm going to look at my information. So 500 commuters polled, some drive to work, some take public transportation, and some do both. So there's an intersection going on here. So information we need is 200 commuters drive and 125 use both types of transportation. And I have to consider, my question is, how many commuters take public transportation? Okay, I'm going to go ahead and utilize my Venn diagram here to play this out. Okay, so I know from my information that, let's see, 200 commuters drive to work, 125 use both. So there's my both. And if I know that 200, that this circle right here represents 200 people, then I know that 200 minus 125 is going to give me the numbers that are just driving. Okay. Now in order to find this piece right here, if we come back up to my information, I see that we looked at 500 commuters. So I'm going to take my 500 commuters, and I'm going to need to subtract out this entire circle. But I'm taking out my drivers, I'm going to subtract those out, and then which gives me 425. And then I want to subtract out the middle ones, the overlap, because I don't want to count them twice. And I'm going to end up with 300. So that tells me that there are 300 people that just take public transportation. But I got to come up to the question here and make sure I'm answering the right question. And it says, how many commuters take public transportation? Well, the ones that take public transportation is going to be this entire circle here. So I am going to need both of the 300 and the 125. So the 300 and the 125 will get me an answer of 425 people do take public transportation. I'll show you the rest of the steps here. There you go. All right, I want to give you a chance to do it. So go ahead and press pause and see how you do with this. Go ahead and make a Venn diagram and answer the question. All right, this is what I found. I have honor students on one side and I have officers on the other. I did have to subtract out 20 minus 9 to find my 11 that are just honor students. And then I took my total 30 students, and I subtracted out the 20 that I knew that was already accounted for. And I found out that there were 10 officers that are just in that officer position. Reading symbols of an inequality. Perfect. Let's play this out here. Now notice what's interesting here is we know that our two equations are 2x minus 1 is less than 3 and 2x minus 1 is greater than 3. But we can turn that into a compound inequality right here by just taking this piece and tacking it on the end here. And you can see how this plays out. We see 2x minus 1 is less than 3. We can see 2x minus 1 is greater than negative 3. So you'll probably start getting in the habit of doing that. Instead of writing two equations, you'll just go ahead and turn it into a compound inequality, because you can then continue with your steps. Add 1 to both sides. And I'm left with negative 2, 2x, and 4. Next step would be divide by 2. And then I'm left with negative 1, and I'm left with 2 on this side right here. Now the solutions of the inequality are given by this statement, which we found, and we can write it as x is greater than -1 and x is less than 2. And this is the notation we would use to represent what we said, where we're saying x such that x is greater than -1, and the intersection of x such that x is less than 2. So we're looking at this as an and. Whew. Now I want you to give it a try. So let's do this for both of these and compare them. And in the end, you're going to end up writing this in that notation form. So see how you did on that. So press pause and take a few minutes to work on that. All right, a couple of points of detail on here on equation A, inequality A. I'm looking and I'm seeing that my symbol is not flipping. I still played it out. Rather than writing it as two equations, I wrote it as a compound inequality. And I played it through, and I can see my answer, my notation here, where x such that x is greater than or equal to 3, with a union of x such that x is less than 6. And my other equation, so our inequality at the actual is the absolute value. Whew, going at B here. I'm going to go ahead and just build my compound inequality in this situation. And I'm looking here, and a detailed piece. Nope, no symbols flipped on this one. And I play it out here where x such that x is less than -2 is a union of x such that x is greater than 5. All right, these take a little bit to do and take some time, but with some practice, you'll be fantastic at it. All right, there you go. I'm going to go and free a walrus from the local zoo. Take care.